Okay, hi all. Good evening. So yesterday we were discussing about gravitational force. So uh, first of all, you remember all those things, whatever we have discussed?
Yes, sir.
Okay, fine. Proceed further today. Just a minute. Getting some background noise from Krishna side.
Not my side, sir.
Okay. Okay, fine. We should start now. So yesterday we have discussed about gravitational force. And we learned that everything is getting attracted towards Earth because Earth is exerting a force, gravitational force, correct? So not only Earth is attracting us, but we are also exerting force on Earth. But because the magnitude of that force is very less, very small, that is why we could not see Earth moving, right? Correct,
Yes,
no?
sir.
And then the another example is the moon is rotating around the earth. So that is also one proof. Okay, earth is exerting force on moon as well. Okay. So we learned yesterday any two objects they exert force on each other. Hope this is clear.
Yeah, yes, sir.
Yeah, yes, sir.
Okay. So now today we will see. Okay. Today what we'll see. These are all things we have discussed. This force of attraction between objects is called the gravitational force. So force of attraction between two objects is known as a
Gravity
gravitational
force.
force. So now after that, we will derive a formula for that. Like yesterday we have discussed, okay, Earth is exerting a force on objects. The objects are also exerting force on Earth. But what is the magnitude of it, right? We don't know that. So today we will derive a formula to find what is the magnitude. Okay, got it?
Yes, sir.
So, universal law of gravitation. Every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. It is known as universal law of gravitation. What is the universal law of gravitation? I think Manaswini, you can go on it. Okay. So this universal law of gravitation states that every object, okay, every object in the universe attracts every other object. So is Krishna attracting the wall present in your house?
Meaning of valve, sir.
Sorry?
What is the meaning of valve?
What you told wall?
Oh no, wall.
Wall, okay. So Krishna is attracting wall. Similarly,
No, sir.
is no, why no?
Like I'm not going near the wall, right, sir?
No, no, see. I'm telling each and every object in this universe attracts each and every other object.
Oh,
Okay.
yeah.
So today we will discuss the formula for it. The force is along the line joining the center of two objects. Suppose this is object A and this is another object B. Okay. And the distance between their centers is a small d. You could see this
Yeah, yes, sir.
diagram. Is this visible?
Yes, sir.
So the gravitational force is along the line joining the center of two objects. Suppose I have an object A here. This is an object B. So the
Yes,
line which is joining the center of two objects, so the force is acting along this line.
yes,
Is
sir.
this point clear? Now suppose the distance between these two objects is small d. Okay.
Yeah.
So we can tell the force which is exerted. Can you come on video?
My video is off.
It is on. Manaswini, is it possible for you to be on video?
No, sir. I'm
Okay, no
attending
problem.
on phone.
No problem, no problem, no problem, no problem. Take care, no problem. Okay. So the force is along the line joining the center of two objects. So this gravitational force will be along the line which is joining these two objects. Clear?
Yeah, yes, sir. It's clear.
So it is force is equal to G m into m by d square. Okay. So this is the formula. So you see here it is written, no, this force is proportional to the product of their masses. Okay, so whatever is the mass of this and what is the mass of this, so this force is proportional to the product of their masses. It means, suppose I have this is one object.
Yes, sir.
This is A. Okay.
Yes, sir.
This is A. This is another object. This is B. Okay.
Yes, sir.
डॉट यार डॉट कैसे देना है भाई okay so now suppose this is a straight line which is joining their centers.
Yes, sir.
Okay, this is a straight line which is joining their centers. Fine.
Yes, sir.
Okay, so the gravity, so these two objects A and B, they both will apply force on each other. Yes, they both will apply
Yes, sir.
force on each other. Suppose the distance between them is this small d. The small d is the distance between them. Okay. So that is what we are showing you here. Small d is the distance between them. Okay. Now, what is the formula? The formula is this force will be proportional to the product of their masses. It means the force which will act between them, suppose that force is F. So this force F will be directly proportional to the product of their masses. Suppose the mass of this is capital M and the mass of this is small m. Okay. So this force will be proportional to the product of their masses. It means m into m. So it means if the mass is more, this force will be more. If the mass is less, this force will be less. Is this clear?
Yes, sir.
Yes, sir.
Okay. So suppose I will take case one. In case one, I have an object A. The mass of this object is 50 kg. And I have an object B. The mass of this object is 70 kg. Okay.
Yes,
Now
sir.
I have second case two. So here, suppose the mass of this object is 90 kg and the mass of this object is 70 kg. So in which case force will be more? Case one or case two?
Case 2.
Case 2, sir.
Why?
Yes, sir. Case 2.
Why?
Because in a case 2, the object A has more mass.
Hmm.
But in object B, in case 1 and case 2,
Sir, could you repeat the question?
See, my question is case one, object A has 50 kg, object B has 70 kg. Case 2, object A has 90 kg, object B has 70 kg. So my question is, in which case the force will be more?
Sir, in case 2.
Why?
Because in
Sir,
case 2
because
object
more mass, there will be more pressure.
More mass, there will be more pressure. Okay. But here the mass is same, no?
Sir, but in object A, mass is 90 and object B,
Okay.
like,
Okay. See, don't check like that. Take the product of it. What is the product of these two masses? 15 to 70 is how much?
3,500.
15 to 70 is 3,500. Clear? Very
yes, sir.
Sir, you shouldn't keep equal to, sir.
Yes, sir. So 3,500. Now here, this will be 90 into
6,300.
70, 6,300. So where the mass, where the product of mass is more? Oh, Manaswini, I have to mute you. I'm getting
Case
background
2,
noise.
sir.
Sorry for that. So in case 2, the product of mass is more. So you always have to check the product of mass. Got it? If the product of mass is more, the
So your
force will
voice
be.
is breaking.
Is my voice breaking for you as well, Krishna?
No, sir, it's clear.
So Manaswini, maybe you can check your headphone once. Okay.
Yeah, okay, sir.
So in case 2, so okay, whenever you have to check the force between two objects, what you will check? The product of mass. If the product is more, the force will be more. Is that clear? Is that clear?
Yes, sir.
Okay, now case 3. Case 3.
Yes, sir.
Suppose here the weight is 60 kg and the weight of this is also 60 kg. So now tell me one thing. The force will be more in case 1 or case 3.
Case 3, sir.
Why?
Because it's in case 1, the object like the force is 3,500, and here
Hmm.
in case 3, it is 3,600.
You have to multiply both the
Okay.
masses, right? So it will be 60 into 60. How much? 3,600.
3,600.
So case 1 product of mass is 3,500. Case 2 product of mass is 6,300. Case 3 product of mass is 3,600. So in which case the product of mass is more?
Uh,
Maximum. In
uh,
case 2, it is 6,300,
yeah,
right?
in case 2, yes, sir.
So here the force will be maximum. Okay?
Yes, sir.
And in which case the
Yes,
force
sir.
will be minimum? Case 1.
Case 1.
Here it is just
Minimum, yeah,
3,500. Yes. So whenever you have to check force, don't check individual masses. What you have to check?
have to check
Product of masses.
product of the masses.
Force is directly proportional to the product of mass of each object. Okay. That is what is written here, which is proportional to the product of their masses and inversely proportional to the square of the distance between them. What is the meaning of this?
What's it there?
See, suppose, let's take a new example. Okay. Case 1.
Yes, sir.
Case 1, here the object, 50 kg, 70 kg, but the distance between them is, let's say, 10 meters. Okay,
Yes, sir.
now take another case. They both have the same masses, but here the distance is, suppose, 5 meter. Okay, so now
Yes.
tell me, 1 minute, give me 1 minute. So now tell me, in which case force will be more?
Yes, sir.
What is the product of mass here?
Yes.
15 to 70, 3,500,
3000.
correct? What is the product of mass here?
3500.
Now the product of mass is same, right?
Yes, sir.
So now how you will find in which case the force will be more? Now you have to check the distance. Okay. Force is inversely proportional to distance. Do you know the meaning of inversely proportional?
Mostly. In one value it is less and another value it is more.
Inversely proportional means when a particular value will decrease, the other value will increase. Okay. And if the other value will decrease, that particular value will increase.
Yes,
Got
sir.
it? Suppose I will write A equals 1 by B. Okay. A equals 1 upon B. Okay.
Yes, sir.
So suppose if the value of B is 100, so what will be the value of A? 1 upon 100?
Yes, sir.
It will be 0.01. Correct?
Yeah, yes, sir.
If the value of B is 50, what will be the value of A? 1 upon 50?
Yes, sir.
That will be 0.02. Are you
Point.
understanding?
Yeah, yes, sir. I'm understanding.
Okay. If the value of A is 25, sorry, value of B is 25, what will be the value of A? 1 upon 25?
Yes, sir.
0.04. If the value of B is 10, what will be the value of A? 0.1.
Yes, sir.
If the value
Yes,
of
sir.
B is 1, what will be the value of A? It will also be 1. Correct?
Yes, sir.
Now, check the relation between them. What you observed, can you tell me? Very simple. Think over it and tell me what you observed.
In A it is increasing and
Hmm,
in B it is decreasing.
good. So if you see B value is decreasing, no?
Yes, sir.
So the B value is decreasing. What has happened to the A value?
A is increasing.
A is increasing, right?
Yes, sir.
Correct now. So when the B is decreasing, A is increasing, right? So that is what known as inversely proportional. Understood?
Yes, sir.
Manaswini, is this clear?
Yes, sir.
Understood the meaning of inversely proportional? No, inversely proportional means if something will decrease, the other thing should increase. Okay, and vice versa.
Yeah, yes, sir.
Okay.
Yes.
So this force is inversely proportional to the square of the distance. Force is inversely proportional to the square of distance. It means F is inversely proportional to 1 by d square. Got it?
Yes, sir.
So if the distance is more, force will be more or less.
Force will be more.
No, you have not understood. You have not understood. See, what is the meaning of inversely proportional? First of all, tell this.
Suppose we will be taking two quantities A and B. So if A decreases, B increases. If B increases, A decreases. Vice
Hmm.
versa.
So what I'm telling here, force is inversely proportional to the square of distance. So force and distance, what is the relation between them?
Inversely proportional.
Inversely proportional. So if the distance will decrease, force will increase or decrease.
If distance increases, force will decrease.
Right?
Yes, sir.
Now, if distance will decrease,
Then force will increase. Vice versa.
got it?
Yes, sir.
Manaswini, is this clear?
Yes, sir.
So now tell me, in case one, case two, in which case distance is less?
Um, in case in case two, distance is less.
Krishna, are you doing something else?
No, sir. In case two, the distance is less.
Why you're taking this much time to answer just a silly question?
No, no, sir. Like I'm seeing the distance, sir. What distance? There is 10 meters and down is 5 meters.
You are not browsing anything, right?
No, sir.
Okay.
Not browsing anything.
So in case one and case two, if you compare, in case two, distance is less. So if distance is less, force will be more or less.
Force will be more, sir.
So now tell me in which case force will be more, case one or case two?
So second case.
Case two,
Second
sir.
case, because in second case distance is less, so force will be more.
Yes,
Okay.
sir.
Yes, sir.
Think Krishna has not understood. Let me give another example. Case one, suppose distance is 20 meters.
Sir.
Case two, distance is 50 meters. In which case force will be more?
In case one, sir.
Why?
Because distance is less.
Now is this clear?
Yes, sir.
If the distance is less, force will be more.
More.
Got it?
Yes, sir.
Okay. Now suppose I have a case three. And here the distance is 5 meter. Now tell me in which case force will be maximum.
Force will be maximum, sir.
Hmm.
In distance, in case three.
In case three, why?
Because distance is very less.
Because distance is the least here. Got it?
Yes, sir.
Okay. Another example. Case four. Case four. Object A mass equals to 80 kg. Object B mass equals 70 kg. Case 5. Object A mass
80
is
kg.
Okay, 90 kg. And object B mass is 80 kg. So tell me, in case 4 or case 5, if you compare these two cases, in which case force will be more?
Sir, in case 5.
5, sir.
Why, Manaswini?
Sir, because as compared to case 4, the product of case 5 is more. Like
Hmm.
90 into 80 is 7,200 and case 4 is 5,600. So case 5 will have more force.
Hmm.
Sorry, more.
Correct. So here you have to check the product of masses, right?
Yes, ma'am.
So here, what is the
Yeah,
product of mass? 80 into 70 is how much?
5,600.
Correct. 90 into 80 is how
7,200.
much?
7,200.
So in which case the product of mass is more?
Sir, in case 5,
Case 5. So case 5 will be having more force. Clear?
more force. Yes, sir.
Krishna Swami, is this clear?
Yes, sir, it's clear, sir.
Okay. Next scenario. Case 6. Distance is 1 meter. Case 7. Distance is 2 meters. In which case force will be more, 6 or 7?
Sir, in case 6, force will be more.
Why?
Sir, because distance is inversely proportional to force. If distance is less, the force will be more.
You have to tell force is inversely proportional to distance.
Okay,
Okay?
force is inversely proportional to distance.
So we have 2 points now. Okay, I will write here important points. Point number 1, force is directly proportional to product of masses. Okay,
Yes, sir.
force is inversely proportional to square of distance. Okay,
Okay, sir.
so if I will ask you what is the square of distance here, what is the square of
So
1?
1,
1. What is the square of 2?
4,
What is the square of 50?
2,000, 2,500.
Krishna, why you are not responding?
Sir, I'm responding. I said I told 2500.
I have not heard.
My mic problem.
My problem. Okay.
2500.
So these two are the important rules which you have to remember. That is what written here. Every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. Got it?
Yes, sir.
So now tell me, two friends, one is in Bangalore, another is in Chennai. Okay? So case one, we have two friends, Tom and John. They are staying in, Tom is in Hyderabad,
Yes, sir.
John is in Bangalore. Okay. Second case, two friends, Harry, Rakesh. Harry is in US, Rakesh is in India. In which case force will be more? And suppose they
Case
all have
2,
the
sir.
same mass. Uh,
Case 2, sir.
Case two, force will be more.
More.
Okay, good. Why, Krishna?
Because, sir, from US to India, it has more distance.
More distance. Very good. Very
No,
good.
sir. What is your question, sir?
Sir, then case
More
1
distance.
will have
Hmm.
more force.
Case 1, sir.
Where are you, Krishna,
I
today?
didn't understand your question, sir,
So
properly.
you have to understand it, no? You have to listen carefully. That is what is lacking in you, concentration.
No, sir.
No, okay, okay. So if you think that okay, concentration is not lacking, okay, fine. So where the distance is more in case two or
In
case
case
one?
1, sir. Case 1, sir.
Sir, in
Very
case
good.
1.
Case 1 distance is more. Very good, Krishna. Very good.
Sir,
Case
case
1
2, sir.
Sir,
distance
in
is more.
case 2, distance
Case
is
2,
more. Case
sir.
1, distance is less.
So in which case force will be more?
Case,
Case. Okay, good. Good.
case 1, sir. I didn't even tell that number only.
Now is this clear?
Yes, sir.
So if the distance is less, force will be.
More.
If the distance is more, force will be.
Less.
If the product of mass is more, then force will be.
Force will be more.
Manaswini,
Sir,
I've asked a question. What was
sir,
that?
in which case force will be more.
If the product of mass is more, force will be more or less?
More.
More. Okay. Now is this clear?
Yes, sir, it's clear.
Okay. So this is the formula F equals to Gm into m by d square.
Yes.
So m into m, what is this? Product of mass. D square is the distance square. This is what we have discussed now. So you see, F is in numerator, M and M is in numerator. If both the quantities are in numerator, that will be directly proportional. Got it? If if one quantity is in numerator, another quantity is in denominator, that will be inversely proportional. This is the trick to find it. Is that clear?
Yes, sir.
Yes.
Okay. If I will write C equals to D, so C and D are directly proportional or inversely proportional?
Directly.
No, you have not understood. See, listen, I could not find that confidence in your voice. If two quantities both are in numerator, it will be directly proportional. Is this point clear?
Yes, sir, it's clear.
I repeat, is this point clear?
Yes, sir, it's clear.
Yes, sir.
If one quantity is in numerator and the other quantity is in denominator, then it will be inversely
Inversely
proportional.
proportional.
Now is this clear?
Yes, sir, it is
Okay.
clear.
Yes, sir.
If I will write x equals 1 by y, what is the relationship between x and y? Directly proportional or inversely proportional?
Inversely proportional.
Manaswini,
Yes, sir. Could you repeat?
x and y are in which relationship? Directly proportional or inversely proportional?
Sir, inversely proportional.
Why?
Sir, because y is in the denominator.
Correct. Y is in denominator, x is in numerator.
Numerator.
Clear? Okay. R equals S. Which relationship?
Directly proportional.
Directly proportional. Q equals 4 into D. What is the relationship?
What, sir?
Sir,
Q equals 4 into
directly
D.
proportional.
Directly proportional. Q and D, they both are in numerator, yes or no?
Yes, sir.
Yes, sir.
Now don't get confused. It is multiplied by 4. Don't worry about 4. Just check Q and D. Are they both in numerator?
Yes, sir.
Directly proportional. That's all. Is this clear?
Yes, sir.
Yes, sir.
See, this is how you have to study. I would have directly told you, okay, acha, this is the formula to find the gravitational force. But then you will not understand what is the meaning of directly proportional, what is the meaning of inversely proportional. So then how you will understand all these examples, the different examples, different cases which we have studied. Okay.
Yes.
So
Okay,
that's why
sir.
whatever you are studying, you have to study in full in depth. Then you will become different in the class. You want to
Yes.
become different or you want to become part of the crowd? Tell me first of all.
Part
No,
of
sir, different.
Part of the crowd.
No.
Krishna wants to become part of the crowd. Okay, good. Manaswini wants to become different. So for Krishna, this is sufficient. Krishna, F equals G, M into M by D square. Okay. You are happy now. You can go and enjoy your life. And for Manaswini, for you, these all are the cases you have to understand. Okay, is this clear?
Right.
Yeah. Yes, sir.
So Krishna, you can go now. Take some cold drink, lassi, juice, Hyderabad biryani. Enjoy your life. Okay, no problem.
No,
Because
sir.
we want to become part of the crowd, but Manaswini wants to become a very great scientist like APJ Abdul Kalam. Okay, very good. Is this clear to everyone?
Yes, sir.
Okay,
Yes, sir.
I think Krishna has dropped now. Okay, fine.
Sir,
Okay,
I
Krishna,
am here
Tata,
only,
bye.
sir.
Take care.
Why I will drop from your class, sir?
Because you told Ki, sir, I don't want to study in depth. I want to become part of the crowd only. Oh, fine, okay. I will call to Mr. Padu today. No issues.
Ah, I told for fun, sir.
Okay, for fun. Okay. So
Cheating,
this is
sir.
the formula, right?
Yes,
So
sir.
F is directly proportional to M into M or inversely proportional. Tell me.
Yes, sir.
Here in this formula, force is directly proportional to product of masses or inversely proportional.
Inverse.
Sir, no,
Very good,
directly
Krishna. No,
Directly
no,
proportional.
proportional.
it
Directly
is
proportional.
fine. It
Directly
is
proportional.
fine for Krishna Manaswini. He told me he wants to be part of the crowd, so he can tell anything. Okay. So it is inversely proportional for Krishna. Manaswini for you,
Sir, it is directly proportional masses
directly
of like
proportional.
products of
Okay.
mass.
Because F is in numerator. M into M is also numerator. Clear?
Yes, sir.
Okay. Now next question. Are you ready?
Yes, sir. I'm ready, sir.
F and D square are in directly proportional or inversely proportional. This is a buzzer round.
Mm,
So could you repeat?
F and D square are they in directly proportional or inversely proportional?
inversely proportional.
Inversely proportional. Very good.
Yes,
So
sir.
now this is clear.
Yes, sir.
Yes, sir.
Okay. Is this clear? You all understood?
Yes, sir. I understood.
Yeah, yes, sir. I understood this.
Okay. So the gravitational force between two objects is directed along the line joining their centers. This is a very, 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 very important point. If
VIP,
someone
sir.
will ask you what is the line of action where the gravitational force is acting between these two objects, so you have to tell कि join their centers. So the gravitational force will act along the line which is joining their center. Okay.
Okay, sir.
Sir, is
So
that a
a
VIP, sir?
sorry.
Is that point VIP?
This is a very, very important point. VIP point. Correct. Okay.
Sir.
Got it. Just give me 1 minute here. 1 minute.
Sir.
Okay. So A will apply force on B, yes or no?
Yes, sir.
B will apply force on A, yes or no?
Yes, sir.
Yes, sir.
Yes, very good. So where A will apply force on B, it will apply in this direction, right?
Yeah, yes, sir.
It will throw it away.
No, sir.
Tell me where A will apply force on B. It will apply
On
force in
B.
this direction.
On B, sir.
It will apply force on B. What in which direction? On this the right side. Okay, it will apply force on top side
No, sir. In a
in
straight
upward
line, sir.
direction.
It'll apply force on a straight line direct.
A will apply force on B in this direction. It will attract it here. Got it? And B will apply force on A in this direction. It will attract it here. Got it?
Yeah.
Yes, sir.
So A will try to attract B towards it. B will try to attract A towards it. Is that clear?
Yes, sir. Understood, sir.
Is that clear?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, very good. Very good. Very good.
Confidence.
Full confidence. Let two objects A and B of masses M and M lie at a distance d from each other as shown in figure 9.2. That is what I told you here.
Yes, sir.
Okay, this is an object A of mass. Where is that? Where is that? This object A of mass capital M, this object B of mass is small m. Where is small m? Okay, and the distance between them is D. So the force of attraction between two objects be F. Suppose the force of attraction between them is F. Always the force you have to represent by capital F. Got it?
Yes, sir.
Okay. According to the universal law of gravitation, the force between two objects is directly proportional to the product of their masses. This is what we have studied now, no?
Yes, sir.
And this is the symbol of directly proportional. You could see this symbol zigzag.
Yes, sir.
This is a symbol of directly proportional. So the force is directly proportional to product of masses. It means if the product of mass is more, force will be more. If the product of mass is less, force will be
Less.
less. Is that clear?
Yes, sir. It's clear.
Yes, sir.
Okay, great. And the force between two objects is inversely proportional to the square of the distance between them. Right now we have discussed this.
Yes, sir. Discussed.
Yes or no?
Yes, sir. We discussed.
Manaswini madam, yes or no?
Yes, sir.
Okay. So force is inversely proportional to a square of distance, but directly proportional to product of masses. Is it looking like heart?
Which one, sir? Yes, sir.
Looking
Where
like
the
heart, no? I'm an artist, okay? So next day I will draw your picture, Krishna.
no. Yeah. Okay, sir.
Okay.
No, sir. Draw
So
Manaswini's picture.
Manaswini's picture is very difficult to draw. I will draw your
Really?
picture, okay?
Sir, it's very easy, sir.
Okay. Hold on. Okay.
Just
Come
So
on,
this
bro. I'm gonna draw yours and send it to you, okay?
Manaswini will draw
come
your
draw
picture,
then.
Krishna,
You're
okay?
gonna regret it. You'll regret it.
Okay, Krishna, be
I'm an
aware, okay?
artist.
Okay. So, okay, you both will draw your own picture, okay? After the class. Is that a fair task, right?
Okay. No, sir. To prepare us
Yeah.
for science exam.
Okay. See, so equation one is force is directly proportional to product of the masses, correct? And here force is inversely proportional to a square of the distance. This is equation two. Now, if you will join equation one and equation two, you will get this equation. Is that clear?
Yes, sir.
Yes, sir.
Okay. So here you could see force is directly proportional to product of the masses, inversely proportional to d square. So what we have done, we have joined this first equation 9.1 and the second equation 9.2. So finally we have this equation. Is this clear?
Yes, sir. Yes,
Understood the
sir.
meaning of this?
Yeah, yes, sir. I understood.
Okay. Now this directly proportional symbol we have to remove. This directly proportional symbol we have to remove and we have to give equal sign, and then there will be a constant which is G. So G is known as constant of proportionality
Okay.
and also known as gravitation constant. And its value is fixed, which I will show you after this.
Like there, sir.
6.7 10 raised to minus 11 Newton meter square kg inverse square. But we will come to that later point of time. But is this clear?
Yes, sir.
Yes, sir.
Okay. So now this is the final formula. F equals G M into M by D square. But how we got this formula? Is that clear?
Yes, sir. It's clear.
Okay, very good. So are you enjoying? Are you understanding the class, guys?
Yes, sir.
Okay, good. Now, next one. What is G here?
He is the constant of proportionality or universal gravitation constant, sir.
Correct. You in shortcut you can tell G is the gravitational constant. Okay. Now tell me one thing. How suddenly we got G here? What is the reason to give this G here? Why?
Don't know, sir.
Tell me.
Don't know, sir.
Don't know. Right now I explained, no?
Because of gravitation.
Because of gravitation. No.
No, it is used as constant of proportionality. For proportionality.
Constant of proportionality.
Sir, your screen is off.
Screen is off. Is it not visible for you as well, Manaswini?
Sir, I
Manaswini.
can't. Yeah.
Now it is
Sir, I
visible.
can see.
It is
It is
visible for
visible.
Manaswini Krishna. You are telling lie, Krishna.
Now it is visible, sir. Before it's not.
Sir,
Okay, no problem.
before it was not visible, sir.
Okay, so okay, fine. So why we got G here? Who will answer? I will get a virtual Kit Kat.
Kit Kat, sir. I want real Kit Kat, sir.
Real Kit Kat, you have to come to my native place, Krishna.
Sir, no need, sir. Do courier, sir.
I will courier. Okay, I will ask that delivery by Amazon. They will deliver it. Okay. Okay.
No need, sir. Do one thing. Come here. Come to
Okay.
Hyderabad.
Okay. No. 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 Stop. Stop. You will start narrating a story, man. Okay. See how we got G here. So what is this symbol?
Symbol. It is
So directly proportional to its. Yeah,
This
directly
is a
proportional.
proportionality symbol. Okay. So when you are doing mathematical calculations, you cannot use this proportionality symbol. You
Oh,
have to use
so
equal
we
to.
equals to. Okay.
So to remove this, I want equal to sign. I have given equal to sign. But in the entire physics, okay, whenever we will remove this proportionality sign, we will give a constant along with it. So that is the reason we have this constant capital G here, which is known as gravitational constant. If someone will tell you, okay, ask you, okay, how suddenly you got this capital G, so what you will tell? It is because we are removing this proportionality constant symbol, and for this we have equals to and then capital G, which is a constant. So it is a rule. Whenever you will remove the proportionality constant, you have to give a constant value. So here this constant value is G. Is that clear?
Yes, sir.
Krishna Swami, is this clear?
Yeah, yes, sir. It's clear, sir.
Okay. So then how we got this formula here? Who will answer?
Like by multiplying cross price.
So we multiply d squared to the left side, it will become f into d square, and this is g m into m, right? Okay. So now let me write this here.
Sir, I'll come in 2 minutes, sir.
Okay, fine. I'm waiting. Come first. Is the board visible, Manaswini?
Yes, sir. It's visible.
Okay, okay, fine, good. Oh, it is very thick line. One thin line.
Yes, sir. I can. I can.
Are you back?
Yes, sir.
Okay, now we'll do some drawing. We will enjoy. Okay. How to draw that thick line here? I forgot it. I think this is the one. Where is that thick line here? This is the fill. Okay, so we have written F equals to G M into M divided by D square, right? Correct now? This is the formula. Yes or no?
Yes, sir.
Okay. Now, 1 minute here. Pencil is there. They don't have any other option. Text, bold. No. Okay. So now we can write here F into D square equals to G M into M. Can
Yes,
we
sir.
write like this?
Yes, sir.
Okay. Now further, if I will move this M into M to the left side, what it will become?
FD square by mm. Sir, your handwriting is very nice, sir.
Oh, great. You're making fun of me, Krishna.
No, sir, it's real, sir.
So you have to pay penalty of 1 lakh rupees, okay?
What I did, sir? I didn't
That
even
means
damage your iPhone, sir.
okay, so can we write like this? G equals FD square by M into M.
Yes, sir.
You know this rule, this M into M is in multiplication. If it will go to the left side, it will become in division.
Yes, sir.
So G equals FD square by M into M. Is this clear?
Yes, sir.
So that is what you have here. Yeah. G equals FD square by M into M.
Yes, sir.
Okay. Now we have to find the unit of G. What is the unit of G?
Is unit 6.673.10.
Oh no, man. I'm asking the unit. You are telling me the value, Krishna.
Unit is newtons.
Krishna, you know one thing, you are always in a hurry.
Sir, like I heard it like it is like how what is the value of G?
See, again you stopped me. You're not, let me complete, you will stop me because always you're in a hurry.
Sir, you didn't even tell anything,
See,
sir.
again you stopped me. I have not completed my statement and you again interrupted because you're always in a hurry. Then same thing you do in exams as well. You will write in a hurry, you will write something in paper, in answer sheet, and your marks are getting deducted because of this only. So I will take you to a homeopathic doctor.
Sir, why, sir?
I will ask them to decrease the speed of Krishna Swami. He's always in a hurry, always 80 kilometers per hour speed he's moving.
Sir,
You have to be calm, little bit slow, listen carefully, full concentration. I know you're browsing something. I'm very much sure, Krishna.
what are you doing, sir?
You're doing something else in your laptop.
What are you doing, sir?
It is visible in your specs actually.
Sir, it is your drawing, sir. It is your beautiful masterpiece. It's very
Okay.
nice.
Okay, tell me what is the unit of force?
Newtons.
Newtons. Newtons. Okay, very good, Krishna. Newtons.
Newton, sir.
Newton. D square. In what unit we measure distance? Ninth class.
Meters.
Meters. So this D will be meters, so it will become M square,
M square, yes, sir.
right?
Yes, sir.
And this M is mass. We measure mass in which unit?
Kg square.
Kgs.
We measure mass in kg square. Very good, Krishna. Very good. We measure mass
Sir,
in
two masses are
kg
there, right,
square.
Kg.
sir?
Okay,
Two
okay.
masses are there, right, sir?
Today I will announce. Okay, I will announce on YouTube. Okay, today onwards, Krishna scientist is telling mass has to be measured in kg square. Okay, very good.
Sir, no,
So
sir, there are two
Manaswini, we
masses like
measure mass in which unit, Manaswini?
Sir, kg, sir.
Kg. So M unit is kg.
Sir, I told for both,
No,
sir.
no, for. So I asked you for both, Krishna.
No, sir.
No, it is because I am telling you are always moving at 360 kilometers per second speed. Okay, and you will enter in space after some time because you're
Sir,
exceeding the
even
escape velocity. Okay, hold on. No, stop. In which unit we measure a small m? This is also mass.
kg.
So grams.
No, this mass will also be in kg.
kg
Okay.
Okay.
So what will be the final unit? Newton meter is square.
by kg.
By kg square.
Very good.
So Newton meter kg whole power square.
So now if you will move this to the numerator, what it will become?
Newton meter square kg square.
It will be in minus, right?
Yes, sir. How will it be square, bro?
It will be minus 2. It is rule of mathematics. If you're moving denominator into the numerator, the sign will change. If it is in plus, it will become minus. If it is minus, it will become plus.
Plus.
Yes, sir.
Clear?
Yes, sir.
So this is the unit of G.
Yes, sir.
Newton meter square kg minus 2. So now if you will check here, unit of G is Newton meter square kg minus 2. Can you see here?
Yes, sir.
Yes, sir.
Clear?
Yes, sir.
Yes, sir.
So next class I will ask this question, derive the unit for gravitational constant. So next class for the first 15 minutes I will take a quick quiz, and whatever I have covered I will ask it. Hope this is clear.
Tomorrow, sir.
Yes, sir.
Yes, the next class will be tomorrow.
Yes, sir.
So tomorrow.
Tomorrow we have class, no?
So tomorrow is Thursday, sir.
So additional class I have to take, no? This week Monday we have
Sir,
not
but
taken class, right?
Sir, I have an exam tomorrow. Like
Oh,
day
tomorrow you
of.
have exam. So when you will be available?
Sir, Friday you can take it.
Okay, Friday I will take. So whatever I have covered, you have to revise it. Okay, now see, one more thing I will tell you. Don't get afraid. Oh my God, sir is teaching all these things. This is very tough. This is very complicated. Appa, Amma, what to do? In book it is
No,
very
sir.
simple, but sir is teaching all these useless things. Don't think like this. But one student is thinking, I know that, and his name starts with K. So if you
Sir.
want to, I have called your name. Tell me, Krishna Swami.
Like, no, not me then.
I just told there is one student whose name starts with K. You are not the only one student whose name starts with K. K for Karan, K for many other things are there, right? So why I'm teaching all these things? Because I want my students, they should know each and everything in full in depth, how the formula is getting derived, what is the meaning of directly proportional, what is the meaning of inversely proportional, why we are giving constant. All these scenarios are very important. Now Friday I will take test in the first 15 minutes, and all these things I will ask again.
Sir, on Friday
Okay?
I'm going to.
Okay, sir.
Okay, fine.
Sir,
Okay, we will. Krishna, what you're telling?
on Friday I'm going to trip, sir. So I'm not available.
That is what I told in the beginning. You told no, I want to enjoy my life. I want to become part of crowd. So go with in the trip with the crowd. I don't
Sir,
have any
it's
concern.
just an educational trip, sir.
Okay, no problem. Enjoy your life, Krishna. Manaswini, we will connect on Friday. Okay.
Sir.
Okay,
Chalo. Okay. Take care. Bye.
Sir.